Alright, so welcome everyone. In this lesson, we're going to talk about some tiny, minute, interesting particles that are the sand particles which will going to create or accentuate the process of realism, because sands, when it travels or even stay at rest also, we're going to see some important minute particles, very tiny particles that basically differentiate from one another and bring some much more realism to the sand. So the same process we're also going to achieve with the help of the nucleus particles. All right, so as here you can see in my scene, I do have some objects kept. Well, we're going to use them as a rigid body so that if in case the particles may to collide to them, so they'll respond properly. So the first step would be to go and create the particles. So in my case, I would like to switch to the end dynamics and just make sure that at the moment you click the particles, your particles should be set there to the point. Okay. So now the question comes that what should be my, what should be my strategy? Well, the simple answer is that we want particles to get driven from the creature. So the answer comes in a way. The creature will going to be the emitter for the particle, and that clearly depicts also that the creature will be the emitter and the emitter type will be set that into the surface. Okay. So what I'm going to do is that I need to select this creature and go to the end particles, then go for the create end particles, and let's say emit from the object. Well, while in the emit from the object, make sure that the emitter type should be set that in the surface. And let's say just for the beginning of the test, I would like to go for, let's say 6,000 as my initial count. But the end result we're going to take to somewhere around, I should say, 100,000 particles or maybe 200,000 particles. Okay. So that's going to be fine because, these particles will obviously going to be in we can say a lot of numbers. The quantity will obviously going to be the big, so we need to have that settings in our scene. Okay, so of course we do have some settings also. What I've did is that here, let me just open the distance and direction attributes for you also. Here you can see that the max distance and the min distance I have also utilized. Well, for the reason let's say we just tweak some values. Let's say we put min distance as 0.1 and the max distance should be 0.25. All right. This I'm doing this because I want my particles to just come out from the surface a little bit more at an offset value. Okay, so that the particles shouldn't seems to be like coming from the surface, or some of the particles may could get missed or so to avoid that, I'm using the distance direction attributes. Next comes to the speed. Speeds will obviously going to play an important role. So what I'm going to do in this case, I'll increase the speed. Let's say the speed of approximately, I think 2 should be good. And the random speed I've given 3, so that means it's going to play the role of +3 or -3. So that will be fine, I believe so. And the tangent speed doesn't have to do here. The normal speed, obviously we are using the emit from the surface, so from the surface now the particles will also going to have some extra speed, but don't give this attribute too much, otherwise the particles will just come out like with very unusual speed, so you can control them. Rest, I don't tweak anything, so I think so this section is clear. So we hit the button create. All right, and now, the another important thing is that, guys, when I used to play, you can see that my particles are, really bouncing a lot. This will, I mean, this is very, very common. That's used to happen. And oh my God, here you can see that so many particles are also getting wasted at downside also. So what happened that if in case we are using, hundred thousands of particles, obviously a scene will going to be get too much dense, and the processor, or you can say the compute will going to be too much. So just to avoid that, I'm going to use some tricks. How? Well, first of all, select this nucleus node, and here you can see that in my case the ground plane has set uh, to the use plane. But what will happen? Just see. I think so nothing should happen. Yeah, that's the problem. Uh, since the particles, is given with the nucleus plane and the distance is set that into 0, 0, 0. So that's basically a common problem. So how to address that's very simple. Just to make you more visually clear, what I can do is that let's first of all see this is the point where is the 0, 0, 0 values. Okay, instead of bringing back down, just don't do anything, just go to the create and go for the measure tool, go for the distance tool, and get the appropriate idea where exactly is your nucleus plane located. I think for 8 should be the complete. Yeah, 8 is a good value, so we can select this one, and let's say I think so 0.75 should be okay, 7.8. So what I can do is that just can select the nucleus, and onto the y-axis I can give the negative, I think the plane origin, yes. Let's say 8 would be the perfect start, sorry, -8, I'm sorry, -8 would going to be the perfect start for me. Now if you're going to play, so here you can see that now the particles are actually coming, and the good thing is that none of the particles is going down, so that's something very good. The reason why I'm using this strategy, because as told you in the beginning also, when we're going to use a lot of particles, let's say not thousands, but hundreds of particles, and maybe it can go to the millions also, and of course it will go to the millions. I think so in my case the maximum particle count that I observed was somewhere approximately to 1 million, I should say. So in 1 million particle count, your scene will obviously going to be really very slow, and the FPS count will also going to be very dip. 0.1, 0.2, I think was the FPS I just noticed. So that's not going to be fair. But by using this approach, you can see that the particles are actually not coming. Okay, so that's absolutely fine. But as you can see that these particles are not basically looking no way like sand, because there could be certain reasons. Let's just start examining them. What should be? Well, first of all, the thing is that let me just go to the particle nodes, and let's say what we can do first of all. So first of all, let's say switch off this drag. I don't need them at all, no problem. And let's say just go to the nucleus node, and under the nucleus node I'm going to give some important settings. First of all, the substeps I'm going to take that into the 5, and the max collision iterations also go into the 5. You can go for 6 also, it's not a problem. And everybody is aware of the fact that what exactly is the meaning of the space scale. Those who need a little bit refreshing, I can tell you, space scale is basically the unit of the physics, what it actually used to calculate in the nucleus dynamics. What exactly it does is that since the Maya standard units are basically in the centimeter, but this solver reads the 1 unit of Maya centimeter as a meter. Let's take a very simple example that you are having a 1 cube that's made up of 1, 1 and 1 xyz. Okay, so that 111 cube will be treated as a 111 meter. So if we're going to solve the physics, the gravity, which is 9.8 meter per second square, based upon that. So it could be you must have observed in your simulations that when you start playing with the timeline, the scene will going to be a little bit slow or not according to your expectations. Then you may increase the value of the gravity. That is okay, but not the very perfect way of working. So the better thing is that you should stay focused to the space scale. And space scale is not just like that we are using in this scene. We have in some previous tutorial also, I have like in the DMM with the bulb shattering effect simulation tutorial, I've also explained a lot on the and focus and concentrated on the space scale also. So just for this case I'm going to use it to 0.1, so that will be fine. And let's say what changes we could get. Okay, no problem. But this is not all which we are looking forward for. We're going to have a lot of changes, so don't worry. So what I'm going to do next is that first of all, I think so that much is fine. Now let's time to work upon the air density also. So this attribute will also going to give me it'll gonna make the surroundings much more dense, and based upon this the sand will obviously gonna come a little bit more slow. Okay, so that's going to be perfect. But here one more thing you can see that, guys, these particles are not getting affected by the behavior of the creature. As I told you that in case of the fluids also, when this particle was shaking his head or raising his arm from the ground, the particle should also react to the body movement of this creature, which in this case is not happening. The simplest way to address is that you can go to the particle shape. Now there is something called the emission attributes. Luckily we are in front here. Emission attributes, see also emitter tabs. So there's something called inherent factor. Inherent as a word suggests that something from the previous you can say. So if the inherent factor I'm gonna switch to 1.5, it'll definitely gonna bring some changes. Let's say what you're gonna do for us. Play. Now you must have seen that now these particles are like the way I just do one thing. Yeah. So here you can see that when it is shaking the head towards this side, now the particles are moving to this direction, to this direction. So that's really going to be very important for us. And what next I could do is that, guys, let me just play around with some more values. However, that's really going to be very simple. We do not need to require a lot of attributes. Let's say in my case I use the bounds of 0.25, and in the nucleus node also we can utilize a bounds. So let's say 0.1 will also be going to good, no problem. And I think so the rest is fine. We can give some noise in the wind. Let's say 1 would going to be fine. That will also going to add some more disturbances in the particles. That's completely good, not a problem. And I think so the speed of the particles are still a bit high. So the best way to address is that I can dip down the normal speed to, let's say, 1 again. Yes, now we're getting to the rhythm. Okay. What happened if we have a speed of 15? Now let's just take a moment. Okay, so that's really going to be a big problem. That's what's happening in the beginning. Just be careful with the fact. You know what actually it is doing? Just imagine this, the thing that every polygon surface has a normal, which is basically the visual clue line, which is perpendicular to the center of the face. Now, to that direction, the speed is, accentuating. So the particles are basically pushing to the direction of the normals. So obviously, I'm not going to use that. And if I'm going to put that to 0, then see, this is also not going to work properly for me, although it seems to be good, but I'm not going to use that one. So minimum 1 value I'm going to give. And let's say the speed random is also a bit high. So what if I give 1 only? Well, that's good, because sand, they also do takes times to uh, to to settle down, or their speed is also really very important. So let me just do one thing. I'm gonna put that thing to 1 again. 1 and -1 would be fine. So that's fine. It's completely okay. And let's just do one more thing. The min distance, I think the min distance is fine. It's not a problem. Okay, that's great. Now what we're gonna do, let me just increase the count from 6,000 to, let's say, 25,000. I'm sure that machine will going to be very heavy, no doubt, but let's just play it, because the more detail we can get, the better realism we're going to achieve. Okay, so not a problem. That's fantastic. The inherent factor is very going to be important, guys, so just don't forget to not to use it. Okay, just for that's very important. Okay, so that's fine, not a problem. And I do have got some renders also, which I'm going to show you at the end of the lesson. Alright, so now we're going to jump to the next lesson, where we're going to cover the stuff related on the particle shading. Alright.